March 27, 1977, 5:06 p.m. Los Rodeos Airport, Tenerife, Canary Islands. 2 Boeing 747 jumbo jets, 583 human beings, 12 seconds. That's all it took for aviation's deadliest disaster to unfold on a fog-shrouded runway 2,000 feet above the Atlantic Ocean. But here's what haunts investigators to this day. The man at the controls of KLM Flight 4805 wasn't some reckless cowboy. He wasn't undertrained. He wasn't incompetent. He was the best pilot KLM had. Captain Jacob Veldhuyzen van Zanten, 50 years old, 11,700 flight hours. Chief flight instructor, head of KLM's entire flight training department, the face of the airline in advertisements. So trusted that when KLM executives first heard about the crash, they immediately wanted Van Zanten to lead the investigation. Then they realized he was the one who had just killed 583 people. How does the most experienced, most respected, most safety-conscious pilot at one of Europe's premier airlines make a decision so catastrophically wrong that it would change aviation forever? The answer lies in a psychological phenomenon that didn't even have a name in 1977. Something that happened in the thousands of hours Van Zanten spent in a simulator, where takeoff was just a word, clearance was instantaneous, and mistakes had no consequences. Welcome to the story of how the safest place in aviation became the most dangerous training ground for disaster. February 5, 1927. Lisse, Netherlands. Jacob Louis Veldhuyzen van Zanten was born in the heart of Holland's Tulip Country, a region famous for precision, order, and discipline. 20 years later, on June 21, 1947, he earned his private pilot's license. By April 18, 1950, he had his commercial ticket and began working for KLM Royal Dutch Airlines as a flight director. This was the golden age of aviation. Propeller planes were giving way to jets. The world was shrinking, and young Jacob van Zanten was there for all of it. In 1951, he started as a first officer on the Douglas DC-3. Throughout the 1950s and early 1960s, he systematically climbed the ranks, collecting qualifications like a collector gathering rare stamps. Flight radio telephone operator's license on September 22, 1952. Airline transport pilot's license on October 19, 1956. Flight navigator's license on August 6, 1963. Each certificate was another step toward mastery of his craft. But the real turning point came on January 23, 1971. Van Zanten was type-rated on the Boeing 747, the queen of the skies. The jumbo jet had only been in commercial service for a year. It was the largest passenger aircraft ever built, capable of carrying over 400 people across continents. It was a technological marvel, a flying palace of aluminum and ambition. Later that year, Van Zanten and 2 colleagues flew to Seattle, Washington, to take delivery of KLM's very first Boeing 747. Registration, PHBUA. Nickname, Mississippi. They ferried it back across the Atlantic to Amsterdam's Schiphol Airport. For Van Zanten, it wasn't just a delivery flight. It was a coronation. He had become one of the elite few qualified to command the most sophisticated aircraft in the sky. By 1976, Van Zanten's career had reached its apex. He was promoted to chief flight instructor and head of KLM's flight training department. His job was to train every single KLM pilot who would ever touch the controls of a Boeing 747. He personally instructed hundreds of captains on emergency procedures, navigation systems, and operational standards. He was responsible for simulator sessions, certification programs, and the safety protocols that kept KLM's reputation sterling. His colleagues described him as studious, serious, introverted, but with an open-hearted and friendly disposition. Jan Bartelski, a contemporary KLM captain who knew Van Zanten personally, later wrote that he was regarded as the company's pilot expert on the Boeing 747 systems. Van Zanten believed in partnership so deeply that he insisted his first officers call him Jaap, a friendly Dutch nickname, rather than Captain Van Zanten. He was Mr. KLM. Literally, the airline used his photograph in advertising campaigns. Passengers saw his face in in-flight magazines. He represented everything the company stood for: safety, professionalism, Dutch precision. When KLM needed someone to represent the airline publicly, they called Van Zanten. Not because of his rank alone, though he was certainly senior enough, but because he embodied the ideal. Jan Bartelski later clarified that Van Zanten was photographed simply because he was always available. While other captains were away flying routes across the globe, Van Zanten was at headquarters, in the training center, in the simulator. And that's where the problem began. For the past 10 years, Captain Jacob Van Zanten had spent the vast majority of his time as an instructor. He conducted training flights almost exclusively. He performed only the bare minimum number of real flights needed to maintain his type rating. In the 12 weeks before March 27, 1977, he hadn't flown a single regular line flight. 12 weeks, nearly 3 months, 0 real-world operations. Instead, he'd been in the simulator, day after day, session after session, running trainees through emergency scenarios, teaching them how to handle the 747, drilling them on procedures. And in a flight simulator, something very specific happens that doesn't happen in real life. The instructor controls everything. In a typical simulator session, Van Zanten would sit beside a trainee pilot and play dual roles, instructor and air traffic controller. The trainee would taxi the simulated aircraft to the runway threshold. Van Zanten would announce, "Cleared for takeoff." The trainee would advance the throttles. No delay, no waiting, no radio chatter, no ambiguity. Cleared for takeoff. Go. Thousands of hours. Thousands of repetitions. A Pavlovian conditioning so deep that it became muscle memory, mental reflex, instinctive response. In Van Zanten's world, reaching the end of the runway meant one thing. You were cleared. You went. The simulator never said, "Stand by for takeoff." And critically, in the simulator, the word takeoff was used constantly, freely, without consequence. We're at takeoff position, ready for takeoff, initiating takeoff. It was just vocabulary, just a word that described a phase of flight. It didn't carry the weight it carried in the real world, where takeoff should only be spoken by a controller giving explicit clearance to leave the ground. The simulator wasn't real. But after 10 years, it had become more real to Van Zanten than reality itself. This phenomenon, this dangerous psychological trap, wouldn't have a name for years. Eventually, researchers would call it simulator syndrome, or training syndrome. The idea that extended time in synthetic environments could actually erode real-world decision-making. That the sterile, controlled, consequence-free world of simulation could rewire a pilot's instincts in ways that made them more dangerous, not less. In 1977, nobody knew this was even possible. On the morning of March 27, 1977, Captain Jacob Van Zanten arrived at Amsterdam's Schiphol Airport to command KLM Flight 4805. It was a charter flight for Holland International Travel Group, a routine hop to the Canary Islands carrying Dutch tourists eager for sunshine and sangria. The aircraft was a Boeing 747-206B, registration PH Buff. On board, 234 passengers and 14 crew members, including Van Zanten. His first officer was Klaus Meurs, 42 years old, with nearly 20 years of aviation experience and approximately 9,300 flight hours. The flight engineer was Willem Schroeder, 48, with over 7,500 hours on the Boeing 747, actually more time in the type than Van Zanten himself. It was an experienced crew, a professional crew, a crew that should have been able to handle anything. At 9 a.m. local time, KLM 4805 departed Amsterdam. Destination, Gran Canaria Airport, also known as Las Palmas, on the island of Gran Canaria in the Canary Islands. Flight time, approximately 3 hours. Weather, clear skies. It should have been completely routine. 3,000 miles away on the west coast of the United States, another Boeing 747 was preparing for a much longer journey. Pan American World Airways Flight 1736 departed Los Angeles International Airport on March 26, bound for the same destination, Las Palmas. The aircraft was a Boeing 747-121, registration N736PA, named Clipper Victor. It was the very first Boeing 747 ever delivered to Pan Am, having entered service in 1970. The Clipper Victor made an intermediate stop at New York's John F. Kennedy International Airport to refuel, change crews, and pick up additional passengers. 14 new passengers boarded in New York, bringing the total to 380. Mostly retirees from California, bound for a 12-day Mediterranean cruise aboard the ship Golden Odyssey. The new cockpit crew consisted of Captain Victor Grubbs, 56 years old, with 21,043 total flight hours and 564 hours on the Boeing 747. His first officer was Robert Bragg, 39, a former Air Force pilot with extensive experience. The flight engineer was George Warnes, 46. They were joined by 13 flight attendants, including senior purser Françoise Colbert de Beaulieu and purser Dorothy Kelly. Just before departure, Françoise approached Dorothy in the crew briefing lounge. She had a request. Françoise was self-conscious about her French accent and worried about making the in-flight announcements. Would Dorothy mind working in first class and handling the PA system instead? Dorothy agreed immediately. It was a small favor, a simple swap of positions. That decision would save Dorothy Kelly's life. At 7:42 a.m. Eastern Time, Pan Am 1736 departed JFK, climbing out over the Atlantic toward Europe and then south toward the Canary Islands. Captain Grubbs settled into the long transoceanic crossing. Everything was normal. Everything was routine. But 2,800 miles away on the island of Gran Canaria, something was about to go very, very wrong. At 12:30 p.m., half past noon, an explosion ripped through the passenger terminal at Gran Canaria Airport. A bomb, planted by the Canary Islands Independence Movement, a separatist group fighting for the island's independence from Spain. 8 people were injured. Chaos erupted. And then came the second threat. Another bomb, somewhere in the airport, waiting to detonate. Spanish authorities made the only decision they could. At approximately 1 p.m., Gran Canaria Airport was closed. All inbound traffic was diverted. KLM 4805, already over the Atlantic and nearing the Canary Islands, received the diversion notice. New destination, Los Rodeos Airport, on the nearby island of Tenerife. It was the only airport in the region large enough to handle wide-body jets. Pan Am 1736, still hours away from the Canaries, received the same instructions. Divert to Tenerife. Wait for Gran Canaria to reopen. Neither crew was happy about it. Los Rodeos was a small regional airport built on a plateau 632 meters, over 2,000 feet above sea level. It had 1 runway, 1 parallel taxiway, 4 short connecting taxiways. It was not designed for heavy international traffic. It certainly wasn't designed for multiple Boeing 747s, but there was no choice. At 1:38 p.m., KLM 4805 touched down on runway 12 at Los Rodeos Airport. The weather was deteriorating. A dense fog was beginning to roll in from the Atlantic, a common phenomenon at the airport's altitude. Visibility was dropping. At 2:15 p.m., Pan Am 1736 landed on the same runway. The Clipper Victor taxied to a parking area near the terminal. Captain Grubbs made a decision. Keep the passengers on board. He wanted to be ready to leave the moment Gran Canaria reopened. No deplaning, no delays. The passengers weren't thrilled. They'd been promised sunshine in the Canaries, not fog and waiting on a cold tarmac in Tenerife. But Grubbs was thinking ahead. The sooner they could get out of here, the better. By 3 p.m., Los Rodeos Airport was in chaos. 5 large airliners had been diverted. The 2 Boeing 747s plus a Boeing 737, a Boeing 727, and a Douglas DC-8. The airport's ramp was completely full. Aircraft were parked on taxiways, blocking normal traffic flow. Ground crews were overwhelmed. Refuelers were scrambling. And then, at 3 p.m., word came through. Gran Canaria Airport had reopened. The bomb threat had been cleared. Aircraft could resume normal operations. Captain Grubbs immediately requested clearance to taxi. But there was a problem. The KLM 747 was parked directly in front of the Pan Am jet, blocking its path to the runway. And Captain Van Zanten had made a decision that was about to set a catastrophic chain of events in motion. He was going to refuel. The flight from Tenerife to Las Palmas was only 25 minutes. The KLM 747 had more than enough fuel to make the short hop. But Van Zanten wasn't thinking about just getting to Las Palmas. He was thinking about the return flight to Amsterdam. If they refueled now, in Tenerife, They could fly to Las Palmas, drop off the passengers, and fly straight back to Amsterdam without stopping for fuel again. It would save time. It would avoid delays at the congested Gran Canaria Airport, where dozens of diverted aircraft would all be jockeying for refueling positions. It seemed like smart planning, but there was another factor, a much more pressing factor. A factor that was gnawing at the back of Van Zanten's mind with increasing urgency. 3 months earlier, in January 1977, the Dutch government had enacted new regulations governing flight crew duty times. The rules were strict. Maximum allowable hours were now tightly controlled. And critically, if a captain exceeded those limits, the consequences were severe. Fines, potential imprisonment, and possible loss of license. It was a dramatic change from the old system, where captains had discretion to extend their duty day if circumstances required it. Now there was no flexibility. The clock was the law. Van Zanten checked his watch. He checked the duty time calculations. By his estimate, they had roughly 2 hours of margin. If everything went smoothly, if they refueled quickly, if Gran Canaria's traffic cleared, if there were no further delays, they could make it back to Amsterdam within legal limits. But if anything went wrong, they'd be stuck. The crew would time out. They'd have to wait for a replacement crew to be flown in from Amsterdam. The passengers would be stranded for hours, possibly overnight. Van Zanten made his decision. Refuel now. 55,000 liters, about 55 tons of jet fuel. It would take approximately 30 minutes. First Officer Robert Bragg and Flight Engineer George Warnes from the Pan Am crew climbed down from their cockpit and walked over to inspect the clearance around the KLM aircraft. Could they squeeze past while the refueling was happening? They measured the gap. They calculated the wingspan clearances. Not safe. Too tight. Bragg radioed to the KLM crew. "How long will the refueling take?" The response came back, crisp and professional. "About 35 minutes. So the Pan Am crew waited, and waited, and watched as precious minutes ticked away. Minutes that were bringing Van Zanten closer and closer to his duty time limit. Minutes that were filling him with a growing sense of urgency, a mounting pressure to get this show on the road and get back in the air. And outside, the fog was getting thicker. By 4:56 p.m., the refueling was complete. KLM 4805 was ready. Van Zanten contacted the tower and requested permission to taxi. The controller approved. Taxi straight ahead on the runway, backtrack to the far end, and turn around for departure on runway 30. Backtracking, taxiing down the active runway in the opposite direction of takeoff was unusual, but necessary. The taxiway was blocked by parked aircraft. The runway was the only clear path. The KLM 747 began its slow taxi down runway 12, disappearing into the fog. At 5:02 p.m., the tower cleared Pan Am 1736 to also backtrack down the runway. The instructions were specific: taxi down the runway and exit at the third taxiway to the left, Charlie 3. Then follow the parallel taxiway to the departure end. But there was a problem. The taxiway exits weren't marked. There were no signs. No painted indicators, just 4 angled turnoffs disappearing into the fog, and a small airport diagram that the crew had to reference on the fly. Captain Grubbs, First Officer Bragg, and Flight Engineer Warnes peered through the cockpit windows, trying to identify the exits as they passed them. "There's Charlie 1, someone called out. They kept moving. Charlie 2, still taxiing. Then they reached Charlie 3. It was a sharp left turn, approximately 135 degrees, onto a narrow taxiway. For a Boeing 747 with a wingspan of 195 feet, it would be a difficult maneuver. Tight, awkward, slow. The crew hesitated. Was this really the turn the controller meant? They kept rolling forward. Just ahead was Charlie 4, angled at about 45 degrees. Much easier, much more logical for a massive wide-body jet. They decided to take Charlie 4 instead. It was a judgment call, a reasonable decision. But it was also a violation of their clearance, and it meant that Pan Am 1736 was now farther down the runway than the tower believed. At the far end of runway 30, KLM 4805 completed its 180-degree turn. Captain Van Zanten lined up the nose with the center line. The Boeing 747 sat at the departure threshold, engines idling, ready to go. The visibility had dropped to approximately 300 meters, less than 1,000 feet. The legal minimum for takeoff was 700 meters. Van Zanten was about to take off in visibility less than half the legal requirement, but he'd already made up his mind. First Officer Klaus Muurs began running through the pre-takeoff checklist. Everything was in order. Van Zanten reached for the throttles. Muurs suddenly spoke up. "Wait a minute. We don't have an ATC clearance." Van Zanten's hand froze on the throttles. He turned to Muurs. "No, I know that. Go ahead. Ask." At 5:05:44 p.m., Muurs keyed the radio. "KLM 4805 is now ready for takeoff, and we are waiting for our ATC clearance." The tower controller responded immediately, passing the departure clearance, the routing instructions for after takeoff. "KLM 8705, you are cleared to the Papa beacon. Climb to and maintain flight level 90. Right turn after takeoff. Proceed with heading 040 until intercepting the 325 radial from Las Palmas VR." It was a standard departure clearance. Instructions on where to fly once airborne. It was not a clearance to take off. But Muurs, reading back the clearance, added something. He confirmed the routing and then said, "We are now at takeoff." 3 words. At takeoff. It was ambiguous. It could mean, "We are now at the takeoff position," a statement of location. Or it could mean, "We are now taking off," a statement of action. In the tower, the controller heard it as the former, a position report. He responded, "Okay, stand by for takeoff. I will call you." But the word "okay" should never have been used. It was non-standard phraseology. And the critical phrase, "Stand by for takeoff, I will call you," was partially blocked. Because at the exact same moment, Pan Am 1736 transmitted, "And we're still taxiing down the runway," the Clipper 1736. Both transmissions happened simultaneously. The radio frequency couldn't handle it. The result was a shrill, piercing heterodyne noise, a 3 3/4 second screech that obliterated both messages. In the KLM cockpit, Van Zanten heard only the word, "Okay." He didn't hear "stand by." He didn't hear "I will call you." And he didn't hear the Pan Am crew saying they were still on the runway. Van Zanten's hand was already on the throttles. He pushed them forward. The 4 Pratt & Whitney JT9D turbofan engines spooled up to full power. The Boeing 747 began to roll. 500 meters ahead, hidden in the fog, Pan Am 1736 was still taxiing down the same runway, approaching the Charlie 4 exit. In the KLM cockpit, flight engineer Willem Schroeder had heard something in the radio chatter, something that made him uneasy. He turned to Van Zanten. "Is he not clear then?" Van Zanten didn't respond. The aircraft was accelerating. Schroeder tried again, louder. "Is he not clear, that Pan American?" Van Zanten's response was immediate and emphatic. "Oh yes." In Dutch, he actually said "Jawel," a forceful affirmative, brooking no argument. The discussion was over. The captain had spoken. The KLM 747 continued accelerating down the fog-shrouded runway, gaining speed, eating up the distance between itself and the Pan Am jet at a rate of 70 meters per second. 9 seconds before impact, Captain Victor Grubbs saw lights through the fog. Lights that were moving. Fast. "There he is!" Grubbs shouted. "Look at him, goddamn, that son of a bitch is coming." First Officer Robert Bragg screamed, "Get off, get off, get off." Grubbs slammed the throttles to full power and yanked the control yoke hard left, trying desperately to turn off the runway, onto the grass, anywhere away from the oncoming jet. In the KLM cockpit, Van Zanten finally saw them. The Pan Am 747, directly ahead, still on the runway. He'd been wrong, catastrophically wrong. He had one option: pull back, try to jump over them. He hauled back on the yoke with everything he had. The nose came up violently, too violently. The tail struck the runway with a sickening screech, dragging for 22 meters. The aircraft shuddered into the air, barely flying, nose pitched at an impossible angle. For a moment it looked like it might work. The KLM's nose wheel passed over the Pan Am's fuselage, but the rest of the airplane didn't. At 5:06:50 p.m., traveling at approximately 140 knots, KLM Flight 4805 slammed into Pan Am Flight 1736. The KLM's landing gear, engines, and lower fuselage ripped through the top of the Pan Am jet like a giant saw, tearing away the entire upper fuselage from just behind the cockpit all the way to the tail. The impact sheared off the Pan Am's tail section completely. The KLM 747, its landing gear destroyed, its engines torn from the wings, struggled into the air for another 150 meters before gravity took over. It crashed back onto the runway, slid another 300 meters in a grinding, screeching mass of tortured metal, and exploded into a massive fireball. Inside both aircraft, fuel ignited instantly. The flames reached 600 meters into the sky. All 248 people aboard KLM Flight 4805, 234 passengers and 14 crew, including Captain Jacob Veldhuyzen van Zanten, died instantly or in the fires that followed. On Pan Am Flight 1736, the destruction was total in the center and rear sections, but the front of the aircraft, the cockpit and forward cabin, remained relatively intact. Captain Grubbs, First Officer Bragg, and Flight Engineer Warnes survived. So did Dorothy Kelly and 3 other flight attendants. In total, 61 people escaped from the front section of the Clipper Victor. 335 people on the Pan Am flight perished. 583 dead. The deadliest accident in aviation history. And it happened on the ground. In Amsterdam, KLM executives received the first reports of a major accident at Tenerife involving one of their aircraft. They immediately thought of their best pilot, their chief instructor, the man who knew Boeing 747s better than anyone. "Get Van Zanten," someone said. "He'll lead the investigation." Then someone checked the flight roster. Jacob Van Zanten had been the captain of KLM 4805. The man they wanted to investigate the crash had caused it. The fog lifted over Tenerife on the morning of March 28, 1977, revealing a scene that would haunt the aviation world for decades. 2 Boeing 747s, one reduced to a burnt-out shell, the other torn apart like a sardine can, sat in twisted wreckage on runway 30 at Los Rodeos Airport. 583 people dead. The deadliest aviation accident in history. And the world wanted answers. Within hours, investigators from 3 countries descended on Tenerife. Spain's Civil Aviation Accident and Incident Investigation Commission, known by its Spanish acronym CIIAC, would lead the investigation as the accident occurred on Spanish territory. But they were joined by teams from the Netherlands, representing KLM and the Dutch government, and the United States representing Pan Am and the Federal Aviation Administration. Approximately 70 personnel worked the investigation. Engineers examined wreckage. Metallurgists analyzed fracture patterns. Pathologists worked to identify remains. And crucially, investigators recovered both cockpit voice recorders, the CVRs that would reveal, in chilling detail, exactly what had happened in those final minutes. When they listened to those tapes, they heard something that would change aviation forever. They heard a perfect pilot make an impossible mistake. The Spanish investigation began with the physical evidence. The impact point was clear. KLM Flight 4805 had struck Pan Am Flight 1736 approximately 1,800 meters from the departure threshold of runway 30. The KLM aircraft had been traveling at approximately 140 knots, about 160 miles per hour, when it attempted to lift off. The tail had dragged on the runway for 22 meters, leaving deep gouges in the asphalt. The aircraft had managed to get airborne, but not high enough. The nose wheel had actually cleared the Pan Am's fuselage, passing just overhead. But the main landing gear, the lower fuselage, and all 4 engines had slammed directly into the top of the American jet. The Pan Am's upper fuselage, from just behind the cockpit all the way to the tail, had been completely ripped away. The impact had been so violent that parts of both aircraft had literally vaporized in the heat and force of the collision. The KLM 747, with its landing gear destroyed and engines torn from the wings, had struggled another 150 meters through the air before crashing back to Earth, sliding 300 additional meters, and exploding in a fireball that consumed everything. The physical evidence was clear. This was a high-speed collision. The KLM had been taking off. The Pan Am had been taxiing. They should never have been on the same piece of runway at the same time. But why? How had this happened? The answer was on the cockpit voice recorders. The CVR from KLM 4805 captured the final minutes in Captain Van Zanten's cockpit, The investigators listened to it dozens of times, transcribing every word, every pause, every nuance. What they heard was a tragedy unfolding in real time, but not in the way anyone expected. At 5:05:44 p.m., First Officer Klaus Mears transmitted to the tower, "KLM 4805 is now ready for takeoff and we are waiting for our ATC clearance." The tower responded with routing instructions, where to fly after departure. Then Mears read back the clearance and added 3 words. "We are now at takeoff." The phrase was ambiguous. Did it mean, "We are now at the takeoff position"? Or did it mean, "We are now taking off"? In the tower, the controller interpreted it as a position report. He responded, "Okay, stand by for takeoff, I will call you." But that crucial phrase, "stand by for takeoff, I will call you," was partially blocked by simultaneous radio transmission from the Pan Am crew, and were still taxiing down the runway, the Clipper 1736. Both transmissions occurred at exactly the same moment. The result was a heterodyne, a shrill, piercing screech that lasted 3.74 seconds. In the KLM cockpit, Van Zanten heard only the word, "Okay." He didn't hear, "Stand by." He didn't hear, "I will call you." And critically, he didn't hear the Pan Am crew saying they were still on the runway. Van Zanten pushed the throttles forward. The engines spooled up. The Boeing 747 began to roll. Then came the moment that aviation psychologists would study for decades. Flight engineer Willem Schroeder had heard something in the radio chatter, something that bothered him. He turned to Van Zanten and said, "Is he not clear then?" Van Zanten didn't respond. The aircraft continued accelerating. Schroeder tried again, louder this time. "Is he not clear, that Pan American?" Van Zanten's response was immediate and emphatic. In Dutch, he said "jawel," a forceful affirmative. In English, it translates to "oh yes." But the tone conveyed even more. It meant yes, absolutely, without question, end of discussion. Schroeder was the most experienced flight engineer in the KLM cockpit. He had over 17,500 hours on the Boeing 747, more time in type than Van Zanten himself. He had heard the radio transmissions. He had questioned the captain twice. But when Van Zanten said "Joel," Schroeder fell silent. The investigation would later determine that this moment, this failure of a crew member to persist in challenging a captain's decision, was a critical link in the chain of errors. But it wasn't Schroeder's fault. It was the system's fault. In 1977, the cockpit was a hierarchy. The captain was God. What the captain said happened. Challenging a captain, especially one as senior and respected as Jacob Van Zanten, simply wasn't done. It wasn't part of the culture. It wasn't part of the training. First officers and flight engineers were expected to follow orders, not question them. This cultural dynamic had contributed to other accidents in the 1970s. Eastern Airlines Flight 401 had crashed into the Florida Everglades in 1972 because the entire crew became fixated on a landing gear light malfunction and failed to notice they were descending into the ground. United Airlines Flight 173 ran out of fuel over Portland, Oregon in 1978 because the captain was so focused on a landing gear problem that he ignored repeated warnings from his crew about their dwindling fuel supply. The pattern was clear. When crews failed to work as teams, when junior members couldn't or wouldn't speak up, people died. But the Tenerife disaster was different in one crucial way. It wasn't just about crew dynamics. It was about something deeper, something that hadn't even been identified yet. It was about what happens to a pilot's brain after spending thousands of hours in an artificial world where the rules are different. The investigators dove into Van Zanten's recent history. What they found was startling. Captain Jacob Van Zanten had not flown a regular line flight in the 12 weeks prior to March 27, 1977. Nearly 3 months. 0 real-world operations. Instead, he'd been working almost exclusively as a flight instructor. His job was to train other pilots on the Boeing 747, conducting simulator sessions day after day, week after week. He was KLM's chief flight instructor, head of the entire flight training department. He was literally the man responsible for ensuring every KLM pilot knew how to fly safely. But in a simulator, the rules are different. In a flight simulator, the instructor controls everything. When Van Zanten ran a training session, He would sit beside the trainee and play multiple roles: instructor, first officer, flight engineer, and critically, air traffic controller. When the trainee reached the end of the runway in the simulation, Van Zanten would say, "Cleared for takeoff. No delay. No ambiguity. No waiting. Just cleared. Go." The word takeoff was used constantly in simulators. "We're at the takeoff position. Ready for takeoff. Initiating takeoff." It was just vocabulary, just part of the training environment. There was no consequence to using it. There was no risk. It was just a word. And after thousands of hours, after thousands of repetitions, that word, and the behavior associated with it, became automatic. Reaching the end of the runway meant you were cleared. You went. That was the pattern. That was the reflex. That was what the simulator had taught. Dr. John Lauber, a NASA psychologist who would later coin the term crew resource management, examined the Tenerife accident closely. He noted that Van Zanten's extended time away from real-world flying, combined with his intensive simulator work, may have created what researchers would later call simulator syndrome or training syndrome. The phenomenon works like this. In a real aircraft, every action has weight. Every decision matters. Ambiguity is dangerous. You wait for clear, unambiguous clearance. You verify, you double-check. Because if you're wrong, people die. But in a simulator, none of that applies. Mistakes have no consequences. You can crash a simulated 747 into a mountain, press reset, and try again. The trainee walks away unharmed. The instructor gives feedback. Everyone learns. It's safe. It's controlled. It's artificial. And if you spend enough time in that artificial world, your brain starts to treat it as normal. The reflexes you develop in the simulator, the automatic responses, the conditioned behaviors, can override the reflexes you need in the real world. On March 27, 1977, Captain Van Zanten was tired. He'd been on duty all day. He was worried about duty time limits and the new regulations that could cost him his license if he exceeded them. He was stressed about getting his passengers to Las Palmas and back to Amsterdam on schedule. He was operating in dense fog with visibility below legal minimums. He was dealing with an unusual airport configuration, backtracking down an active runway. And in that moment of stress, fatigue, and pressure, his brain reverted to the pattern it knew best. The pattern from the simulator. Reach the end of the runway. You're cleared. Go. When he heard the word OK on the radio, his simulator-trained brain filled in the rest. Cleared for takeoff, even though those words were never spoken, even though his flight engineer questioned him twice, even though every piece of evidence should have told him to stop. He didn't stop, because in the simulator you never stop. In the simulator, you always go. The Spanish investigation team, after months of analysis, issued their final report in October 1978. The fundamental cause of the accident, they concluded, was that Captain Van Zanten attempted to take off without clearance. But they identified multiple contributing factors: ambiguous communications and non-standard phraseology, the use of OK by the controller, the phrase "we are now at takeoff" by the KLM first officer, the simultaneous transmissions that created radio interference, the lack of clear, explicit, unambiguous language, Van Zanten's recent duty time concerns, and the pressure created by new Dutch regulations limiting flight hours. The investigation found that this psychological pressure may have influenced his decision-making, creating a sense of urgency that overrode normal caution. The Pan Am crew's failure to exit at the instructed taxiway. They were told to use Charlie 3, but they continued to Charlie 4 because the turn was easier for a large aircraft. If they had exited at Charlie 3, the collision would not have occurred. The airport's lack of ground radar. The tower controllers could not see the aircraft in the fog. They were managing traffic based entirely on radio communications, with no visual or electronic confirmation of where aircraft actually were. Inadequate runway and taxiway markings. The exits were poorly marked and difficult to identify in the fog. The absence of crew resource management training. The KLM crew did not function as an effective team. The flight engineer's concerns were dismissed rather than seriously evaluated. And crucially, though not explicitly named in the 1978 report, the effects of extended simulator training on real-world decision-making. Van Zanten's simulator mentality. The Dutch investigators initially tried to spread blame more broadly, suggesting that the entire system had failed. They weren't entirely wrong, but the facts were inescapable. Van Zanten had taken off without clearance. In doing so, he had violated the most fundamental rule of aviation, and 583 people had died as a result. KLM eventually accepted primary responsibility for the accident. The airline paid compensation to victims' families ranging from $58,000 to $600,000, equivalent to approximately $300,000 to $3.1 million in today's dollars when adjusted for inflation. But money couldn't bring anyone back, and the aviation industry knew that unless something changed, unless the lessons of Tenerife were learned and implemented, it would happen again. 3 weeks after the Tenerife disaster, NASA organized a workshop. The topic, resource management on the flight deck. It was held in June 1979, and it brought together researchers, airline representatives, pilots, and government officials from around the world. The goal was to understand how flight crews could better utilize all available resources, human, informational, and technological, to prevent accidents caused by human error. One of the key speakers was Captain Al Haynes, who would later become famous for his role in the crash landing of United Airlines Flight 232 in Sioux City, Iowa, in 1989. Haynes would credit the training that emerged from this NASA workshop with saving his life and the lives of many others when his DC-10 suffered a catastrophic engine failure that destroyed all hydraulic systems. The term coined at that workshop was cockpit resource management, later expanded to crew resource management, when it became clear that the principles applied to the entire flight operation, not just pilots. The acronym, CRM, would become one of the most important safety initiatives in aviation history. The core concept of CRM was revolutionary for its time: flatten the hierarchy. Create a culture where any crew member, regardless of rank, could speak up about safety concerns without fear of retribution. Encourage questioning. Promote teamwork. Teach pilots that admitting uncertainty wasn't weakness, it was wisdom. United Airlines became the first U.S. carrier to implement a comprehensive CRM training program in 1981. The program was modeled on corporate management training, focusing on communication styles, leadership, and decision-making. It emphasized changing individual behaviors, teaching captains to be less authoritarian, teaching first officers to be more assertive. The training was controversial at first. Many senior captains resisted. They saw it as an attack on their authority, a suggestion that they couldn't be trusted to command an aircraft. Some called it charm school or touchy-feely nonsense, but the data didn't lie. Airlines that implemented CRM saw measurable reductions in incidents and accidents. By the late 1980s and early 1990s, CRM training evolved. The focus shifted from individual psychology to team dynamics. Airlines like Delta developed modular training programs that addressed specific scenarios: team building, situational awareness, stress management, decision-making strategies, and most importantly, breaking the error chain before it led to catastrophe. The 1989 Kegworth air disaster in the UK provided another crucial lesson. A British Midland Boeing 737 suffered an engine failure, but the flight crew shut down the wrong engine, the good one, and crashed. Cabin crew members had noticed flames and smoke coming from the correct engine, but said nothing, believing it wasn't their role to inform the cockpit. That accident led to another expansion of CRM. It wasn't just cockpit resource management anymore. It was crew resource management, encompassing flight attendants, ground staff, maintenance personnel, everyone involved in flight operations. By 1995, the FAA mandated CRM training for all Part 121 operators, the major airlines. It became a required component of pilot training curricula worldwide. The International Civil Aviation Organization, ICAO, and the International Air Transport Association, IATA, promoted CRM standards globally, ensuring that the principles were consistently applied across different cultures and regions. Today, CRM training is mandatory for all commercial pilots. It's taught from the earliest days of flight training and reinforced throughout a pilot's career. Modern CRM focuses on threat and error management, identifying potential threats before they become problems, and managing errors before they escalate into incidents. Crews learn to recognize their own limitations, to speak up when something doesn't feel right, to challenge decisions respectfully, and to work as cohesive teams. The impact has been profound. Studies have shown that 60 to 80% of aviation accidents involve human error. CRM doesn't eliminate human error. Humans will always make mistakes. But it creates systems and cultures that catch errors before they become catastrophic. Captain Al Haynes, reflecting on his experience in Sioux City, where he successfully crash-landed a DC-10 with no hydraulic controls, saving 185 of the 296 people aboard, said this: "Up until 1980, we kind of worked on the concept that the captain was the authority on the aircraft. What he said goes, and we lost a few airplanes because of that. Sometimes the captain isn't as smart as we thought he was. CRM teaches that the captain is still in command, but command means using all available resources, including the knowledge and observations of every crew member." The Tenerife disaster also revolutionized aviation communication. The ICAO took the disaster as an opportunity to completely overhaul radio telephony phraseology standards. The changes were codified in ICAO Annex 10, Aeronautical Telecommunications, and in Document 4444, Procedures for Air Navigation Services. The most critical change, the word takeoff, was banned from all radio communications except in one specific context, when air traffic control is giving explicit clearance for an aircraft to take off. You cannot say, "ready for takeoff." You cannot say, "we are at takeoff." You cannot use the word at all unless you are a controller saying, "cleared for takeoff." Instead, pilots now say, "ready for departure." Controllers say, "line up and wait" when an aircraft should enter the runway but not yet take off. The phrase, "after departure, fly heading 040, replaced "after takeoff, fly heading 040. The word "okay" was eliminated entirely. It's too ambiguous. Controllers must use explicit, unambiguous terms. Cleared for takeoff, or hold position, or standby. The word "affirm" was introduced to replace casual uses of "yes," ensuring it couldn't be confused with "negative" if part of the word was lost in radio transmission. "Say again" replaced "repeat" because in military contexts, repeat means fire another round of artillery at the same target. A phrase with catastrophic potential if misunderstood. "Go ahead" was replaced by "pass your message," so that the safety-critical phrase, "go around," instructing a pilot to abort a landing, couldn't be confused. These changes were implemented worldwide starting in the late 1970s and early 1980s. They've since prevented countless accidents by eliminating ambiguity at the most critical moments. Another major change: readback requirements. Pilots are now required to read back all clearances, especially takeoff and landing clearances, word for word. Controllers must listen to the readback and correct any errors immediately. This simple practice, say it, repeat it, confirm it, creates a fail-safe against misunderstanding. The Tenerife disaster also accelerated the development and deployment of ground radar systems at airports. In 1977, Los Rodeos Airport had no way to electronically track aircraft on the ground. Controllers were blind in the fog. Today, virtually all major airports have sophisticated ground radar systems that show controllers exactly where every aircraft is, in real time, even in zero visibility. Technologies like ASDEX, Airport Surface Detection Equipment Model X, use radar and multilateration to track aircraft and ground vehicles on airport surfaces. When combined with automated alerts, these systems can warn controllers if two aircraft are on a collision course, providing critical seconds to prevent disaster. Runway and taxiway lighting has also been dramatically improved. Los Rodeos in 1977 had inoperative centerline lights and poorly marked exits. Modern airports have sophisticated lighting systems that guide pilots even in the worst visibility, with clear, standardized markings that are visible from the cockpit. Perhaps most importantly, the Tenerife disaster changed the culture of aviation safety itself. Before Tenerife, many accidents were viewed as pilot error, and the response was often punitive. Blame the pilot, punish the pilot, move on. After Tenerife, the industry embraced a systems approach to safety. Accidents are almost never caused by a single error. They're caused by chains of errors, multiple failures that align in just the wrong way. James Reason, a British psychologist, developed what's now called the Swiss cheese model of accident causation. Imagine multiple slices of Swiss cheese stacked together. Each slice represents a layer of defense, training, procedures, technology, checks and balances. Each hole in the cheese represents a weakness or vulnerability. Normally, the holes don't line up. If one layer fails, another catches the error. But occasionally the holes align. An error passes through one layer, then another, then another. When enough holes line up, disaster occurs. Tenerife was a perfect example. Multiple failures aligned. The bomb threat diverted aircraft. The small airport was overwhelmed. The fog reduced visibility. Van Zanten's simulator conditioning made him hear what he expected rather than what was said. The radio interference blocked critical messages. The flight engineer's concerns were dismissed. The Pan Am crew missed their exit. The controllers had no radar. Each failure by itself would have been survivable. But altogether, they created catastrophe. Modern aviation safety focuses on identifying potential holes and plugging them before they can align. It's called error management, or threat and error management. The goal isn't perfection. Humans can't be perfect. The goal is resilience. Building systems that can absorb errors and still remain safe. This cultural shift, from blame to learning, from punishment to improvement, from hierarchy to teamwork, is perhaps Tenerife's greatest legacy. Today, commercial aviation is the safest form of transportation in human history. The fatal accident rate for commercial aviation worldwide is approximately 1 fatal accident per 10 million flights. You're statistically safer in an airplane at 35,000 feet than you are driving to the airport. That safety didn't happen by accident. It happened because people learned from tragedy. It happened because 583 lives lost on a foggy runway in Tenerife forced the aviation world to confront hard truths about human nature, crew dynamics, communication, and the dangers of complacency. Every time a pilot says, "ready for departure," instead of "ready for takeoff," that's Tenerife's legacy. Every time a first officer challenges a captain's decision and the captain listens, that's Tenerife's legacy. Every time a crew works together as a team sharing information and watching out for each other, that's Tenerife's legacy. Captain Jacob Van Zanten didn't want to be remembered as the pilot who caused history's deadliest aviation disaster. By all accounts, he was a good man, a skilled pilot, a dedicated instructor who loved flying and wanted to make it safer. He made a terrible mistake, a mistake compounded by stress, fatigue, time pressure, inadequate procedures, poor communications, and yes, the psychological effects of spending too much time in a world where takeoff was just a word and mistakes had no consequences. He paid for that mistake with his life. So did 247 other people on his aircraft. So did 335 people on Pan Am 1736. But their deaths were not in vain. The aviation industry took those lessons and built a culture of safety that has saved countless thousands of lives in the decades since. The changes implemented after Tenerife, CRM, standardized phraseology, ground radar, improved training, better communication, flatter hierarchies, error management, have made the skies safer for everyone. Willem Schroeder, the KLM Flight engineer, questioned his captain twice. In 1977, that wasn't enough. Today, in a cockpit shaped by CRM training and Tenerife's lessons, that questioning would continue until the doubt was resolved. Today, Van Zanten would be trained to listen, to pause, to verify. Today, the system would have multiple safeguards to prevent that error chain from completing. Today, 583 people wouldn't die on a foggy runway because of a word. The monument at Mesa Mota in Tenerife, designed by Dutch sculptor Rudy van de Wint, is called Stairway to Heaven. It's a spiral staircase rising into the sky, its steps climbing endlessly upward before being cut off suddenly, symbolizing lives ended too soon. Every year on March 27th, survivors, family members, and aviation professionals gather there. They remember the dead. They honor the survivors. And they recommit to the principle that has guided aviation safety ever since. Learn from every error. Improve every system. Never let it happen again. The deadliest disaster in aviation history wasn't caused by terrorism or mechanical failure or weather. It was caused by human beings making very human mistakes under stress, in an imperfect system, with inadequate training and poor communication. But those humans, flawed, tired, pressured, doing their best in impossible circumstances, taught the rest of us how to be better, how to communicate more clearly, how to work as teams, how to build systems that account for human limitations, how to create a culture where safety comes before schedule, where speaking up is valued, where errors are learning opportunities rather than sources of shame. That's the paradox of Tenerife. From the worst disaster came the greatest improvements. From 583 deaths came millions of lives saved. Captain Jacob van Zanten's simulator mentality killed him, but the lessons learned from his mistake have made the simulator, and the real world, safer for every pilot who came after.